The ABC 1 Hour Cleaner site is a 1-acre site in Jacksonville, North Carolina. It was a dry cleaning facility that operated from 1964 to 2005. Because of contamination found, it is now a Superfund site under the authorities of the United States Environmental Protection Agency. The cleanup prescribed for the ABC Cleaner Superfund site, which began in the spring of 2023, is called in situ thermal treatment with soil vapor extraction. At ABC, this treatment is being used to address soil contamination. The word in situ means in place, and thermal indicates that heating is involved in the treatment. With in situ thermal remediation, heat is applied underground, in place, directly to the contaminated area. The heat is applied in two different ways: by heaters placed in underground steel pipes, and also through steam that is injected into constructed pipes. The heat vaporizes the harmful chemicals. Think of boiling water vaporizing. These vapors move through the soil towards constructed wells, where the vapors are collected and piped to the ground surface to a treatment area where remaining contamination is removed. The following pictures were taken during work at the ABC 1 Hour Cleaner site to help show and better explain this in situ soil vapor extraction process. This is a sonic drill rig, which is used to install wells into the ground. The wells consist of steel pipes that will hold thermal heating elements called heaters. Well locations are marked on the surface with orange paint. The well field takes shape. Once all the wells are installed, foam board is placed on the surface and a concrete cover is poured to provide insulation and prevent loss of heat. System operations begin. The sounds you just heard are the sounds of steam injection. The system for ABC was designed to operate for 4 months. Before the system can be turned off, crews will collect soil samples to determine how well the system has performed. Collecting soil samples from a subsurface environment that has been heated to 212 degrees Fahrenheit requires equipment that can withstand the high soil temperatures. Drill crew members need special protective clothing and gear, called personal protective equipment or PPE, to protect against injury from possible contact with steam, hot water, hot soil, and hot sampling tools. In this picture, drill crew members in PPE are preparing to collect a soil sample from a hollow tube that was inserted into the ground to remove a section of soil for testing. To ensure the soil is not too hot for the plastic, the drill crew places the plastic sleeve against the hollow tube that has just been removed from the ground to ensure the bag would not melt under the hot soil temperatures. Once it was confirmed that the sample bag could withstand the soil temperatures, the hot soil sample was pushed from the core barrel into the sample bag. The plastic sample bag is visible in the center of the picture to the left of the middle crew member. Every effort possible was made to minimize the time that the hot soil sample is exposed to ambient air during this process. The sample bag was immediately sealed by tying knots on both ends. This picture shows a sample bag being placed on ice for cooling to 50 degrees Fahrenheit. This picture shows the temperature of soil immediately after being removed from the ground. Here we see the soil cores cooling prior to sampling. The cooling process took approximately 45 to 60 minutes. In this picture, we see the geologist collecting a soil sample through a small opening in the plastic sleeve. The sample was sent to a laboratory for analysis of site contaminants, including tetrachloroethylene, commonly called PCE. Following completion of the soil boring event, the team placed steel pipes and heating elements into 2 of the soil boring locations to add extra heating. This was done to increase the effectiveness of the thermal treatment. In this picture, the team is adding the heating element which is composed of a long, thin wire and temperature sensors to one of the soil borings. The additional heating will maximize treatment. The in situ thermal remediation system with soil vapor extraction has hit peak mass recovery, and in early April 2024, hot soil boring samples were collected to determine effectiveness. Based on results from the soil sampling, the system has performed above expectations. The team, which included EPA, the North Carolina Department of Environmental Quality, and EPA's remedial action contractors, then met to determine if continued operation of the treatment system would provide additional benefit. After considering the soil sampling results and daily system operation measurements, the team decided that the in situ thermal system would be shut down. Once soil temperatures have cooled, the system will be removed. The treatment for ABC has been successful in reducing the level of contaminants in the soil. Additional soil samples will be taken once the concrete cover is removed to determine if any level of soil contamination remains. Now that the soil cleanup is almost finished, plans are underway to address the contaminated groundwater that remains at the site. The first step will be to sample the groundwater to determine what and where contaminants are located. Some of the typical equipment used for the sampling process is shown in this picture. Sampling and then analyzing groundwater helps the site team experts know where groundwater contamination exists. This information will help the team determine the best approach for the groundwater cleanup at the site. Stay tuned for more updates. Should you have any questions regarding the cleanup, please contact EPA's Remedial Project Manager for the site, Susan Kibler, or Community Involvement Coordinator, Rosemarie Nelson. You may also contact Beth Hartzell, Remedial Project Manager with the North Carolina Department of Environmental Quality. Contact information for the given EPA and state personnel are listed.